Welcome back. Today, we join a builder taking on a machine most people consider safe. This 1971 Chevelle has endured severe fire damage and decades of field rot, leaving only a skeletal shell. The extraction process requires careful winching to avoid snapping the brittle, oxidized frame rails. Heat from a previous fire alters the molecular structure of the steel, making it prone to sudden failure under tension. Securing a compromised chassis demands distributing the load across multiple anchor points. Every rusted component tells a story of intense thermal degradation. The first victory is simply getting the surviving metal onto the flatbed intact. Heavy-duty chains provide the necessary tensile strength to anchor a lifeless chassis during transport. Woven nylon straps stretch under load, but steel links lock the suspension exactly where it sits. Proper tie-down protocol involves crossing the chains to counter lateral sway on the road. The tires, dry-rotted and deflated, offer zero shock absorption. This leaves the trailer's suspension to manage the impact of every bump, protecting the fragile remnants of the Chevelle from further structural stress. Reaching the garage marks the shift from extraction to evaluation. Unloading a seized vehicle relies entirely on mechanical advantage. The steady pull of the winch eases the heavy, rolling dead weight down the ramp. Taillight offers a first glimpse of the restoration environment. A workspace equipped for heavy mechanical revival. The sheer scale of the neglect is undeniable. The engine bay is a cavern of soot and melted plastic. Decades of exposure have fused hardware together, turning every bolt into a potential obstacle. The real work begins beneath the surface. The teardown starts by stripping away the most heavily damaged layers. Copper wiring exposed to extreme heat becomes incredibly brittle. The insulation melts away, leaving bare conductive strands that fuse together in a solid, charred mass. These destroyed harnesses must be completely excised to map the surviving engine architecture. Removing the ruined rubber and plastic clears a path to the block itself. Even the distributor cap, distorted by intense temperatures, is salvaged only for reference. Clearing this debris is essential before any true mechanical diagnostics can begin. focus shifts deep into the intake manifold. Probing the dark recesses reveals the extent of internal corrosion. Extracting the fouled spark plug provides critical diagnostic data. Heavy carbon deposits indicate how the engine was running before it was abandoned. Pulling away the crusted debris allows access to the cylinder. Every piece removed sheds light on the block's true condition. The critical test for any abandoned block is whether the crankshaft will still rotate. Moisture accumulation over decades typically causes piston rings to seize against the cylinder walls. Applying leverage directly to the crankshaft pulley forces the internal components to break their rusted bond. A long breaker bar multiplies the rotational torque. Overcoming that initial stiction is a vital milestone. Once the engine completes a full manual revolution, the possibility of an internal rebuild becomes a reality. The block is salvageable. Moving to the workbench, attention turns to a heavily oxidized donor carburetor. Sourced as a running unit, visual inspection quickly reveals missing linkage clips and significant internal wear. Parts accumulate microscopic corrosion that binds precision metering components. Disassembly requires breaking the friction of oxidized hardware. A socket easily rounds off softened, rusted bolt heads, if not seated perfectly. Tapping the cast aluminum housing with a hammer introduces high-frequency vibrations. This mechanical shock helps fracture the crystalline structure of the rust, freeing seized internal pins. Careful extraction prevents damaging the fragile brass jets hidden inside. Extracting the final rods requires steady leverage. Pliers draw out the corroded linkage elements, piece by piece. White, chalky oxidation on aluminum surfaces indicates prolonged moisture exposure. This galvanic corrosion must be cleared entirely to restore smooth throttle operation. Once stripped, the bare housing is ready for a chemical bath. Back in the cabin, the scope of the interior decay mirrors the engine's challenges. Transitioning to fluid systems, new copper tubing replaces the destroyed pressure lines. Copper is highly malleable, allowing it to be shaped neatly along the valve covers without kinking. Routing these vital conduits through the firewall connects the restored mechanicals to the interior gauges. Tightening the brass fittings ensures a leak-proof seal under pressure. Elevating the chassis onto jack stands provides crucial access to the undercarriage. Floor jacks lift the heavy steel frame, while the stands secure the load against sudden drops. The underside reveals deep pitting and loose exhaust brackets, common in vehicles left resting on soil. Soil traps moisture against the metal, accelerating oxidation far faster than open air. Clearing the underbody allows for visual inspection of the drivetrain. Up top, the master cylinder is checked. The thick, dark fluid indicates years of neglected maintenance, requiring a complete flush of the hydraulic braking system. With the car elevated, the wheels spin freely, confirming the drivetrain isn't completely locked. The late afternoon light exposes the severe degradation of the body panels. Peeling paint and deep surface rust map the areas where moisture sat the longest. Despite the heavy corrosion on the exterior, the structural integrity of the frame rails remains intact. The contrast between fresh fluids and rusted iron defines this phase of the build. The interior holds decades of compacted debris. Removing broken glass and old newspaper insulation from the door cavities is essential to prevent moisture retention. Dirt trapped inside a metal frame acts like a sponge, promoting rust from the inside out. Probing deep into the mechanical voids dislodges the hardened earth. Clearing these narrow channels restores the proper drainage paths built into the original factory design. High suction vacuum nozzle pulls the loose flakes of oxidation from the tight seams. Removing this organic material stops the corrosive cycle. If left unchecked, wet leaves and dirt generate organic acids as they decompose, rapidly eating through sheet metal. A clean inner door skin ensures that future window mechanisms will operate without grinding against the bricks and bricks. The interior is slowly being Under the rusted hood, wildlife has claimed the empty cavities. Clearing out massive piles of pine cones and dry leaves removes a severe fire hazard. Rodents often utilize engine bays for shelter, carrying in combustible nesting materials. Removing this blockage is mandatory before introducing any heat or sparks to the channel. Vacuuming the rusted floorboards reveals the true condition of the sheet metal. Scattered glass fragments and pitted steel tell the story of the car's exposure to the elements. Clearing this grit is the final step of the teardown phase. With the debris removed, the focus can shift entirely to mechanical reconstruction. Replacing the compromised fuel system requires navigating a maze of rusted components. Old rubber lines degrade and crack, turning a pressurized fuel system into a massive liability. Fitting new black hoses ensures safe delivery from the tank to the engine. Locking pliers hold the flexible line secure while new clamps are seated. Below the chassis, the aged exhaust and suspension elements frame the new plumbing. Tightening the bolts on the mechanical fuel pump establishes a reliable pulse of fuel to the overhauled carburetor. Custom metal hard lines require precision flaring to create high-pressure seals. Clamped tightly in a vise, the flaring tool forces the end of the copper tubing outward. This creates a conical seat that perfectly matches the brass fittings on the engine block. A proper flare prevents leaks without relying on chemical sealants. Once shaped, the rigid line is carefully routed around the valve covers, away from the intense heat of the exhaust manifolds. An angle grinder cleans the burrs off the cut metal, ensuring a smooth mating surface. In the cramped engine bay, a new cooling route is established. Bypassing the compromised internal heater core prevents potential cabin leaks. A section of reinforced rubber hose loops the hot coolant directly back into the engine block. Tightening the hose clamps secures the pressurized system. The engine bay is transforming, trading dry rotted rubber for reliable, modern flow paths. Inside the cabin, the original shifter linkage is seized beyond repair. Ratcheting away the rusted nuts frees the old mechanism. A modern aftermarket shifter, retrieved from garage storage, offers precise gear selection. Assembling the new bracket on the workbench ensures all internal detent function smoothly before it enters the dusty cabin. Fitting the new base plate requires modifying the transmission tunnel. An angle grinder slices through the sheet metal, creating the necessary clearance. Sparks trace the line of the fresh cut. The modified floor pan accepts the rigid mounting bracket, bolting down snug against the steel. A solid mount is crucial. Any flex in the shifter base translates to missed gears under heavy load. The mechanism is seated, ready for its linkage. Beneath the floor, the steel linkage rods connect the cabin to the transmission. Locking pliers hold the linkage arms steady while the retaining pins are driven home. Adjusting the threaded rods precisely sets the neutral position, ensuring the transmission engages every gear fully. Inside, the gas pedal linkages are hooked up. A heavy tarp is drawn over the engine bay, closing out the day's mechanical progress. The following day begins with inspecting the rear drum brakes. Pulling the heavy cast iron drum exposes the internal shoes and springs. The deep scoring on the friction surface indicates harsh metal-on-metal contact from neglected pads. However, the wheel bearings tell a different story. Wiping away the dark grease reveals the cotter pin and a well-lubricated spindle. The thick grease survived the fire damage, protecting the critical rotational bearings from heat and moisture. Moving back under the hood, the electrical charging system needs an overhaul. Loosening the rusted mounting bolts allows the old, dead alternator to be extracted. A fresh delivery brings a modern, internally regulated replacement. Unboxing the new unit marks a significant upgrade in electrical reliability. The clean silver casing of the new alternator stands in sharp contrast to the oxidized block. Threading the mounting bolts secures it to the original brackets. Upgrading to an internally regulated unit simplifies the wiring harness, eliminating the need for an external voltage control box on the firewall. On the workbench, a failing starter motor requires solenoid repair. The solenoid acts as a heavy-duty electrical switch, engaging the starter gear when the key is turned. Removing the cardboard dust shield exposes the internal coil spring. A dab of blue thread locker on the mounting bolts prevents engine vibrations from backing them out over time. Crimping a new ring terminal onto the heavy-gauge wire ensures maximum current transfer without excess heat. Once sealed in heat-shrink tubing, the repaired starter is maneuvered into the tight, greasy pocket at the base of the engine block. Underneath the car, wedging a pry bar blocks the engine from turning. This allows the heavy flywheel bolts to be broken loose. Dropping the old flex plate reveals severely chewed gear teeth. When a starter motor is misaligned, the pinion gear grinds against the flex plate, rapidly destroying the hardened steel teeth. A fresh flex plate is unboxed to restore a smooth, reliable engine cranking surface. Fingers guide the mounting bolts into the bell housing by feel in the dim undercarriage. The clean starter motor is bolted tight against the block. A floor jack supports the heavy transmission, while the cross-member bolts are driven home with a power drill. Connecting the spark plug wires up top prepares the ignition system. However, an inspection of the new flex plate reveals a critical mismatch. The bolt pattern fails to align with the torque converter. It is a frustrating setback that requires pulling the heavy components apart and sourcing the correct rotational hardware. With the drivetrain supported, the floor jack slowly lowers the heavy chassis. The suspension compresses under the vehicle's weight for the first time in weeks, settling the frame against the dusk sky. Restoration extends to the exterior safety systems. Soldering iron heat bonds the colored wires to fresh light sockets, creating strong, corrosion-resistant electrical connections. Routing these new harnesses into the empty headlight buckets prepares the front for illumination. A test fit proves the bulbs draw clean power. At the rear, the rusted bumper cavities receive new white plastic taillight housing. Securing them into the heavily pitted chrome requires drilling new mounting points. The bright, pristine plastic sitting within the oxidized metal captures the essence of this build. Functional reliability wrapped in a weathered shell. Inside the dark trunk, the wiring puzzle continues. Feeding the multicolored harness through the rusted interior panels links the rear lights to the main fuse box. Grounding the wires to the bare metal chassis is essential. A poor ground is the leading cause of dim or flickering automotive lighting. The connections are clamped and secured. Under the dash, a new flasher relay is plugged into the dusty terminal block. This small cylinder uses a bimetallic strip that heats and bends, interrupting the circuit to create the rhythmic blink of the turn signals. Testing the circuits confirms the rear lights are fully active. Securing the loose metal trim pieces along the rear frame tidies up the body lines. Peeling away the decayed rubber weather stripping exposes the compromised trunk lid. Applying a thick layer of gray body filler seals the worst of the rust holes. This composite material cures rapidly, blocking water intrusion and stabilizing the fragile sheet metal around the rear deck. The door hinges, stiff from decades of neglect, receive a heavy coating of penetrating oil. The fluid seeps deep into the pivot pins, breaking down the internal rust. At the front of the car, the massive hood hinges present a similar challenge. These heavy spring-loaded mechanisms must be precisely aligned. A depth gauge measures the mounting tolerances on the heavily pitted steel. Proper alignment ensures the heavy hood won't bind or warp the fenders when closed. The final bolts are cinched down on the rusted hood hinges. Every mechanical system has been touched, cleaned, and brought back into tolerance. The engine bay remains a patchwork of burnt orange rust and bright new components. Closing the hood seals the revived powerhouse within its weathered shell. What was a scrap pile is a working machine again. Revived, not factory perfect, and honest about it. Every hidden wire and fluid line they routed is what its reliability now rests on. Some things are worth the long road back.